Hello friends, Rick here, and in this video I'll be talking about time dilation. It is one of the most basic concepts in relativity. Time, as we think of it, it seems to be absolute, but it is actually not. It is different for different observers, it is different for different frames, and it's an axis actually, if we just try to graph it. But for this, we need to have a little concept about relativity. So first, let's begin with what is relativity. Relativity means being relative. So let us take an example of velocity relativity. So for example, I have taken here two cars, this car and this car, and a stationary lamppost. This car is moving at a speed of 5 meters per second. This truck is moving at a speed of 2 meters per second, and this lamppost is a silly stationary object. For this car would seem to be moving at minus 3 meters per second. Remember the negative sign here. This represents the direction. This car will see this lamppost to be moving at minus 5 meters per second. Now let us change the reference point. Let us consider this truck. This truck will see this car to be moving at 3 meters per second. This lamppost to be moving at minus 2 meters per second. Now let us take the perspective of this lamppost. This lamppost will see this car to be moving at 5 meters per second and this car to be moving at 2 meters per second, because it's stationary. But light doesn't obey those rules. Light is an electromagnetic wave. It is not relative. If this car watches this light ray going from the lamppost, it will still be C. If this truck watches this light ray, it will still be C. And if this lamppost is watching this light ray, it will still be C. Even if there is an object moving at half the speed of light, it will still observe this light ray to be C. This is why light is said to be not relative. And this is a big theory, and we would use this to derive time. Let us consider the speed of light to be c. Now, we have a man here whose name is, let's say, A, and he has a clock. Let the time which he observes to be t dashed. Now, here there is a truck moving at v, and inside the truck there is a photon cell. What is a photon cell? It has two mirrors in it, and in the middle there is a photon which is constantly bouncing up and down in the mirror. There is also a clock here, and let the time in the clock be t. Now, the truck is moving at a velocity of v, so let us consider only the photon cell. The photon cell has a velocity of v, this whole apparatus. Now, for the photon, it will seem that it is bouncing just up and down like that. But for Bill, he will observe the photon to be moving in this path. So according to the photon, he is moving this part, that is ct. C is the speed of light and t is the time observed by the photon. From his point of view, the time is t. So this distance is ct. From the perspective of Bill, he sees that he is traveling a longer path. He is seeing from the stationary point of view, he is not moving. So he will see the speed of light times the time in his clock, that is ct prime. And actually the distance traveled here is actually this, between these 2 points is vt dashed, because v is the velocity and t dashed is the time observed by Bill. So here we have a right angle triangle. Let's see how we can use it. Now, here we have our ct, ct dashed and vt dashed moving at the velocity of v. It is a right angle triangle, as you can see. Let's name it ABC. Now, ABC is a right angle triangle, so we can use the Pythagoras Theorem to see ct dash whole squared is equal to vt dash squared plus ct squared. Now just breaking it up, we get c t dash whole square v t dash square plus c square t square. Now we are dividing everything by c square. So we get t dash square is equals to t dash square v square by c square plus t square. That's just simply dividing it by c square. Now I'm just keeping the t in one side and t dash in another side. So here is t is equal to t dash square minus t dash square v square c square. Now I have just factored it out. So just taking t dash square as common, we get t square is equal to t dash square into 1 minus v square c by c square. Now just cross multiplying, we get t dash square is equal to t square over 1 minus v square over c square. Or t dash is equal to t over square root of 1 minus v square by c square. So what do we get? T dash and t. But they are not the same. There is a factor there. Let's see what does it mean. Here it is in all its glory. So we have derived that t dashed is equal to t over 1 minus v square c square, and this is under root. So what does it mean? T dashed, as we saw, is the time of a stationary man. So that's the stationary time, as you can see. T was the time in the clock which was moving, so it is the moving time. And v square, as we saw, is the velocity of the object, and speed of the light is c squared. Now, as you have squared this c square and v square, as v is very smaller than c, so this is actually going to be equal, closely to equal, but not actually equal. But that's not too much noticeable. But actually time is dilating here. So the time of a stationary person will be more than the time of a moving person. In other words, you age slower when you move faster. Now let's talk about why don't we actually observe it. Actually, v is much smaller than c. C is the speed of light, as you know. It's 2994792,498 meters per second. And v in everyday situations is very small as compared to c. So v squared will be smaller than c squared, and it is actually so small that v square by c square is practically 0. So 1 minus v square by c square will also be practically 1. Taking the square root, we get it 1. So that means this denominator is becoming almost equal to 1. Or we can just say that t dashed is almost equal to 2. That's not actually equal, but t dashed is close to 2. That is why we do not observe anything in our everyday life. Because in our everyday situations, v is so small than c that we don't observe it. So, if you have liked this video, please don't forget to subscribe and hit that bell icon. Share this with your friends, and thanks for watching, and thank you.